Yes.
Yeah. How are you today?
Doing good.
Very good. I'll wait for a few minutes for to people to come out. Any question in the meantime? Any questions you may have? We'll wait for a minute or so, okay? Just to make sure that everybody's on board. You folks have any questions for me? I'll wait for a couple of more minutes, okay? Just to make sure that some people may be having little time needing. Did you get your homework assignment? Is due when? When is it due? Next Friday or this Friday?
It's
I
due
believe it's this
December 10th.
Friday.
This Friday? It's on triangles or isoparametric? Triangles, right?
Triangles, yep.
I see. All right, let me start. Let me make sure that you understand the big picture clearly. Just to summarize, recap, cut off all the fluff. This is the bottom line. Number one, you want to integrate a to b f of x dx in 1D. Or you want to integrate integral over the area g of x and y dA in 2D. Or you want to integrate over the volume h of x, y, and z dV in 3D. This is the bottom line, because all of these give you Ku equal to F. And Ku equal to F looks like integral B transpose dB dV in general. F looks like integral over the, let's say, volume N transpose FB dV. These are how the load vectors are integrated. These are how the stiffness is integrated. This could be this, or this, or this in 1D, 2D, 3D. The key is this one, for a bar element, it's like this. For a triangle, it's like this. For a quadrilateral, it's like this. For a tetrahedral, it's like this. Sorry. Tetrahedral element in 3D. Let me hold this carefully. For a hexahedral, it's like this. So this is 3D, this is 2D, this is 1D. Now, so your objective is to integrate these correctly. How? And why? This is the reason why. You can model these for various geometries using these things, elements, which are called. But they all require evaluation of K, evaluation of F. And it's not easy to evaluate these integrals in closed form like we did in 1D. You did EA over L times 1 minus 1 minus 1, 1. It's not easy. 1D is easy, but this creates a major problem. This creates a major problem. This creates a major problem, including higher order. Higher order means higher order. Is like this. What is K matrix for this one? So many nodes, some crazy potato shape. What is the volume of this one? What is integral of the volume V transpose of x, y, z, d, v of x, y, z, d, v? What is it? You go crazy. So what we do is we use Gauss concept to evaluate. That's what the bottom line message is. Is this clear to all of you? Yes or no? Digest it carefully and let's go. Because today is the last day. We'll go through isoparametrics. And on Wednesday, we'll go to do some TA problems, etc., on various things, etc. That's it. Go ahead now. Any questions so far? Any question? So this is the big picture. The big picture is I want to evaluate these integrals because finite element gives me this. But Gauss told me this. We use Gauss concept for these. To evaluate these integrals. Because these integrals look like this. So that's what I'm teaching you. Suppose you're not supposed to do analytically. You want to do numerically. So Gauss integration is the one which you go through, and it is the most powerful thing because for polynomials, you can get exact answer. I can tell you the exact volume of this potato. Exactly. So then you have now Gauss concept. There are three things in Gauss concept. Gauss points, Gauss theorem, mapping, and then what's the last one? Tables. Up to 2n minus 1 through n Gauss points. That's the theorem. Okay, now, to make sure you understand the concepts clearly, we do two things. 1D. We know integral a to b or 0 to L b transpose E b of x dx, a is outside, is equal to E a over L times 1 minus 1 minus 1, 1. We know this is true. But we're going to use numerical integration to get the same thing for you to get confidence of using Gauss integration. That's what I'm doing in 1D, 2D, and 3D. And that is the expectation of the class. Do you understand me? And have I been clear and with clarity? Did I explain to you what is the motivation and why I'm doing this? Is this clear? I need a few yes,
Yes.
or whatever.
Yes, Professor.
One more? One more yes I need.
Yes.
Okay, thank you, sir. Thank you very much. You're very kind. Now, let me show you. That is why I wrote here. We went through this. We went through all of this stuff, teaching you Gauss integration and the basic concepts. Since you know the basic concepts exactly, Now I'm going to go to how to apply and extend that idea to FEM. FEM. The blue shows you FEM from now onwards. Here onwards, FEM. Take these two noded elements X1 and X2. Let me. Okay. Take a look at this. This is the X system. One second. This is the X system. This is the Casi system. I'm not going to do problems here. I'm going to map and do problems here and evaluate the integrals K and F. Is that clear? Is that clear? I'm not going to do the X world anymore. I'm going to do it in the Casi world. Is that okay? Like Laplace transform.
Yeah, it's clear.
Now, in the Casi system, how do you get ends? How do you get ends? There are two ways. Long way, and I'll use another one called short way. Is this clear? Long way means this. Long way. A long way. You assume in the Casi system, you assume the following. U of Casi is equal to A plus B Casi, linear. At Casi equal to -1, U equal to U1, Casi equal to +1, U equal to U2, and you apply and solve for A and B, you get U of Casi is equal to N1, N2, U1, U2. Do all of you know how to do this? Yes or no? Do you know how to get N1 and N2 in the Casi system? Yes or no? You get this one just like this. Like this. Yes. Do you understand how to get N1 and N2? If you solve this, you get this. Last time I showed you this. You apply Casi equal to -1, you want U equal to U1. At Casi equal to +1, you got U equal to U2. U1 and U2 is a linear line. And you solve for A and B, arrange it, and you get this one. Is that clear? I need some feedback. The objective is these integrals, K's and B's, these are function of N's and B's. So I need to know N's and B's all the time. That's why I'm teaching you how to derive the N's and B's. Let me write it a little bit more clearly. Function of N's and B's. So what is N and what is for these elements? What are N's and what are B's? This is the key thing. Once I know the N's and B's, then I can do Gauss integration and show you how to integrate it. Do you understand the motivation? Do you understand the motivation?
Yes.
Okay, now. Do you know the long way how to get? What would you do if you did the, let me do this. In the X system, Do you know how to do this in the X system? Right? I showed you how to do this, correct? Yes?
Yes.
I assume linear. But I'm not going to do this. I'm going to do this because now I'm in the Cauchy system. That's what I'm trying to get at. Is this clear? Why we are in the Cauchy system? You are no longer on Earth. You are on Mars. So in Mars, you do what the Martians do. Go to between -1 and 1 and you work in their atmosphere, not here. Sounds good? This is called the long way. Suppose if you needed a 3-noded element, one more. Suppose I needed a 3-noded element. 1, 2, 3, x equal to 0, x equal to L over 2, x equal to L. Can you tell me what is this? Is a quadratic curve. Therefore, u of x equal to a plus bx plus cx square. That's equal to, that's at x equal to 0, u equal to u1, x equal to L over 2, u equal to u2, x equal to L, u equal to u3, and you plug it and get ABC, and then if you solve, you get u of x equal to n1, n2, n3 times u1, u2, u3. This is called the long way. Is this clear? Is this clear?
Yes.
Yes.
Now, because we are not going to do the X system, we are going to the Cauchy world. This is the X system. We're going to go into the Cauchy system. This is the X system, this is the Cauchy system. Do you understand this one? How to get the N1, N2, and the Cauchy system? Yes or no? You assume a quadratic distribution, apply the conditions, what you want to enforce, and then you can get the ends. That's how the ends are done. And this is called the long way. Do you understand me? Or do I need to explain again? Tell me, please.
That makes sense.
If you don't mind, could you repeat again, please?
Because there are 2 points, I assume a linear line. Because there are 3 points, I assume a quadratic. If there are 4 points, I will assume a cubic. If there are 10 points, I assume a ninth order. And then solve for the constants, arrange them, and put it in this way. That's how you get the ends, either in the X system or the Cauchy system. But right now, we abandon the X system. We are only in the Cauchy system because most finite elements, stiffnesses, and load vectors are evaluated using isoparametric in most commercial codes. Is that understood? That
Yes,
is why
makes
it is
sense.
important for you to understand the concept of isoparametric formulation. Then you take du by dx or du by d Cauchy, and then work it in this as if you're doing the same thing like before. But you have to map it from here to here. Do you understand that? Are you okay with these two thought process?
Yes.
Okay, now if you said yes, now watch. This gives you u of x is equal to ni ui of x. This gives you u of Cauchy equal to ni of Cauchy ui. Right? You understand what I'm saying? Let me make sure that you read this writing clearly. And make sure that you're not missing something. Let me write it out a little bit more. Don't doodle, but I'll write it now. This gives you u of x equal to n1 of x, n2 of x, times u1, u2. Is this clear? This gives you u of cos equal to n1, sorry, my bad. N3 of x times u1, u2, u3. This gives n1 of cos e, n2 of cos e, n3 of cos e times u1, u2, u3. Is this clear? So let me ask you, how do you get the n's in the x system? Can anybody tell me how to evaluate? I'm just trying to regurgitate myself once more. How do you get n's in the x system? You assume a polynomial. You assume a polynomial like this. Oops, what happened? You assume a polynomial like this, apply these conditions and get n's. You assume a polynomial like this, apply the conditions and get this. Is this clear? For 2-noded and 3-noded. Do you understand that? Yes or no? Yes or no?
Yes.
Okay. In the Cauchy system, also, you can do the same thing. And if you do that, you assume a polynomial like this for the 3-noded and get this by applying these conditions. What conditions you do? At x equal to 0, not x equal to 0, sorry. How do you get n1, n2 in Cauchy system? Can you tell me? How do you get these? Can anybody tell me? How did I get these?
You would apply the -1 is equal to a plus b
Yes,
plus
b
c plus
minus 1,
c.
exactly. U equal to u1, that's equal to a plus b times -1 times c plus -1 square, correct? That's one equation, correct?
Correct.
Likewise, we get at Cauchy equal to 0, you get u equal to u2. At Cauchy equal to +1, you get u equal to u3. And then you solve for a, b, c and put it and you get this one. That's how you get. That's called the long way, long way. Right. Let me ask you one question. If I have, what would you do to get the interpolation functions? What would you do? What would you do? If I ask you that in the final exam, what would you do?
It'd be a cubic formula.
Smart guy. You get 5 points, guy. A plus bx plus cx squared plus dx cubed u of x, and then apply the conditions at x equal to 0, L over 4, L over 2, L over 3, 2L over 3, and L, and then get N1, N2, N3, N1, N2, N3, N4 times U1, U2, U3, U4, right? That's what you would do, right? Yes or no? Right? Is that what you meant? When you say cubic?
Yes, that's what I meant.
Okay, now, what would you do in the Cauchy system? Whatever these distances, you do, apply and same procedure. Same, right? U of Cauchy equal to A plus B Cauchy plus C Cauchy square plus D Cauchy cube, and then apply these conditions, correct? Understood? Do you understand me? I need some confirmation. My question to you is, do you understand how to get N1, N2, N3 or any N's in the X system and in the Kasi system? Yes or no?
Yes.
Now, if you said yes to that, whatever you use for N, use the same thing for X. X also, same thing. This is called isoparametric formulation. I use the same thing, and isoparametric means same parameter. That is why it's called isoparametric. Iso. That is why the definition was isoparametric, because I'm using whatever I got for N, I'm using for the mapping also. So this maps 0 to L to -1 and 1. Kasi X. Is this clear? Is this part clear? Very clear to you? If not, stop it. Yes or no? Do you know, for example, look at here. Two-noded element, U of Kasi -1, 1, 1, U1, U2. U of Kasi is equal to 1 minus Kasi over 2, 1 plus Kasi over 2 times U1 and U2. This maps, this is N1 and N2. If I use X of Kasi, I use same 1 minus Kasi over 2, 1 plus Kasi over 2 times X1, X2. This maps X1, X2 to U1, U2. And that's what I was trying to say. That's why it's called isoparametric formulation. Is this clear? This concept? Is that clear? Spend a little time. Understand what I'm trying to say? Remember when we did Gauss theorem? This is the same as this one. They both are same. If you write it A and B, etc., same interpolation as that one. If you use.
Professor,
Yes.
what is X representative in this case where like U is displacement? What is X?
X is a dimension of the body.
Okay.
If you have
So
a
you're
bar,
mapping from one coordinate system to the other.
yeah, this is X1, X2, X3, X4. These are the coordinates of this beam. You're mapping these things into -1 to 1, same things. And you want to perform the integration in this world and forget about this world. Understood?
Yes, thank you.
No, if you feel a little uncomfortable, stop me. Don't let Professor Tama proceed without your permission. Can I go forward or you have a still question?
No, I got it. Thank you.
Okay, now, for example, here is a bar. These are 10 inches. X1 is 0, X2 is 10. You see what I'm saying? I don't care if it's 0 or 10. And I need to do 0 to 10 B transpose E B of X dx A. I'm not going to do this. I'm going to do -1 to 1 and map this one using X equal to Ni of Kasi Ui, and then do integral -1 to 1 B transpose of Kasi E B of Kasi d Kasi. This is what I'm going to evaluate, and the answer to this is Wi Fi. And that's what I'm going to use. And then I'll abandon this guy because this world is difficult. This world, easy. Because when it comes to complex geometries, this world becomes more and more easy. Is this clear? Yes or no? Did you get the message? You can practice it later. This is the first time you're going through. So there may be some inconvenience on your part to say yes. But once you try it out, you'll be okay. Trust me. You understand? Any questions? Now watch. I told you this is the long way. I'll show you the short way. Watch. It's called the, can you summarize? Long way is assume U is a polynomial, linear, quadratic, cubic, etc. Apply the conditions, x equal to 0, etc. and derive it. That's called a long way, or Cauchy. Short way is this. You guys really have to focus. It's called the finger method. I'm going to teach you something called the finger method. It sounds funny, but look at it carefully. The formula, these are called Lagrange polynomials. N's are Lagrange, N's are what are called as Lagrange polys. They are equal to 1 or 0. That's the property. Lagrange polynomials are either 1 or 0 elsewhere. Do you understand about Lagrange polynomials? Have you heard about them before? Have you? Somewhere along in high school or somewhere, have you heard about Lagrange polynomials?
I heard about it, but kind of forget what was
Yeah,
it.
don't worry about the forget part. I forgot what I did yesterday, so I understand that. But did you hear about it at least? Lagrange.
Yes, when I was in the numerical analysis class.
Yeah, good. Now, therefore, to get polynomials, to get Lagrange polys, you use the following method. Cauchy minus the finger divided by finger minus non-finger. Write down this one carefully, please. Write down this formula carefully. I'll tell you what I mean. Just write it down. This is important. It may affect your grade if you don't understand. Ready? I'll tell you how to generate short way. How to generate fast. Generate what? Ends fast. Can I teach you? Now watch. Watch. I have enough space? Yeah. Can I maneuver? What's on the left hand side? 1 second. I'm just talking to myself. Yeah, I feel good. Put your finger on this one. Node 1. Careful. Put your finger on that one. Cover it up. So N1 is equal to, sorry, 1 second. Let me get my color back. If you cover it up, N1 of Kasi equal to, I'm going to use the finger method. Kasi minus the finger. What did you cover? What is the finger? What is Kasi value for the finger? The one you covered it up. What is it? I need your participation, guys.
Minus
It's
1.
a lot of fun. Kasi minus what?
1.
Minus 1, right?
Oh, minus 1, yeah.
Right. Divided by the finger minus the non-finger. What is the finger? What is the finger? What is the value of Kasi for the finger? The one you covered it up. What is it?
Minus 1.
Minus 1. Minus of non-finger. What is the non-finger? Kasi.
Oh, 1.
Plus 1. This is equal to 1 minus Kasi over 2. You see how fast I generated it? Did you get it? Did you understand what I just did? I just derived to you the N1 in a hurry by using this finger formula because I used Lagrange polynomial. This is the Lagrange polynomial behavior. This becomes very important when you do, suppose I said do this one.
Wait, how did you get 1
1 second, sir, 1 second. Don't get excited. I'll be with you. This crazy one, how are you going to do? I'm going to map it. In the Kasi eta system from the XY system and do. I'll teach you how to do all these things now. Before you go home, you'll become the world's expert in Lagrange polynomials. Ask me a question, sir. Repeat.
I was confused how you simplified C plus 1 over negative 2 to be positive 1 minus C over 2.
Yeah. The
Shouldn't it be
first
negative
one,
1
stop.
minus C?
Yeah, watch. Kasi minus the finger. Oh, wait a minute. Did I say that? Kasi minus the sorry. My bad. The formula has, that's a non-finger, not finger. Yeah, my bad. This is it. Do you understand now? I made a mistake. Non-finger. Is this clear? Kasi, watch out. Kasi minus the non-finger. Non-finger is 1 plus 1. And my finger is minus 1. Minus the non-finger is plus 1. Therefore, that's equal to this one. Is this clear?
Yes.
My pen is giving a hard time, I think. Let me see. Is this clear? Yes or no? I'll repeat it again. How about this? I'm going to repeat because I'm a nice guy. Okay.
Is the non-finger always the next value to the right?
Let me just do this one. Don't worry, I'll answer your question. Just hang on. Kasi minus non-finger divided by finger minus non. Do you understand this? This is the Lagrange polynomial. Do you understand this formula? This is the finger, the X. This is the non-finger. You understand?
Is non-finger always the next value to the right?
No, the non-finger is always what you that which is left over after you fingered the particular node. If I fingered 1, 2 is a non-finger. If I fingered 2, 1 is a non-finger.
So what if it's a 3-node element?
We'll get there when we cross it. You're beating me, you're going ahead of yourself. You'll be answering, I'll make you answer the question in about a few minutes. Within the next 5 minutes, I'll answer the question. Okay?
Okay, thank you.
All right. Now, but did you understand what is the finger and what is the non-finger?
Yeah, for
The finger
2-node,
is
yep.
the one, once more. The finger is that which node you're trying to find, you finger that. So the other one becomes a non-finger. If you touch the other one, then the other one becomes a non-finger. Understood? This has to be done live in a class. It's very hard to teach these days, but I think I'll do a good job, don't worry. If you finger this one, this is a non-finger. If you finger this one, this is a non-finger. Understood? Yes or no? No? Yes, maybe? Please help me out here. Again, I'll rewrite it again. Watch this. I just want to make sure. Don't worry, there's plenty of time. N1 of C equal to, here is 1, 2, C minus 1 plus 1. N1, so I finger N1. I finger this one. So what if I finger this one? What would be N1? Read the formula. Kasi minus the non-finger 1 divided by the finger minus 1 minus the non-finger minus 1. This is equal to 1 minus Kasi over 2. At Kasi equal to minus 1, this is 1. At Kasi equal to plus 1, it is 0. That's the Lagrange polynomial. Do you understand what I just said? Yes or no?
Yes.
Okay, now, the same person who said yes to me, give me N2, please. I'll give you 5 points.
N2 is C minus the non-fingered value, and so it would be -1 all over 1 minus -1.
That's N2. It is the same damn answer. As this one. You agree? Isn't that the same as this one? Right? So do you guys know how to get N1 and N2 the short way, the long way? Yes or no? I need some.
Yes, Professor.
I need 3 S's to move. That's very difficult. Otherwise, tell me. Do you
Yes,
understand?
Professor.
One more yes I need to move. Otherwise, my constitution says can't go. One more yes. Do you know how to get N1 and N2 using the finger method, the short way?
Yes, Professor.
Okay, now watch. We'll do something else. 1 second. Earlier, somebody was asking me how to do if you have more than one this thing. I'm going to answer that question right now. All right. There are two ways to get ends. I'll give you 5 points if you tell me the two ways. What are the two ways? Help me out here. Repeat after me. What is the two ways? 5 points. What are the two ways? I can ask you in the exam, give me the long way or give me the short way. Understood? Short way is the finger method. Long way is the polynomial approximation. For a three-noded element, what is the long way? What do you do? You of course see. 5 points. Give me that. Please. Earlier somebody answered this question. What is U of Kasi? Long way. Come on, guys. You can do better.
A
What
plus
do you approximate for you? 3 nodes.
A plus B ka C plus C ka C square.
Exactly. You got 5 points. And then apply the conditions and get N1 and N1, right? N2 and N3, right? You understand that, right? That's tedious. The finger method is what? N1. Watch this one. N1 of Kasi. Finger N1. Finger this one. It is not there. So now use the finger method. What does the finger method say? Read it. Read this formula for that. Read to me. What do you say? If you finger node 1, what happens? Who are the non-fingers? 2 and 3 are the non-fingers, correct? Yes or no?
Correct.
What's that? Yes or no? So it is what? What is the formula? If you finger 1, come on, 5 points. Five easy points. I taught you enough background now. Just spit it out. No brains. Just say it. Read it out.
0
think.
and 1.
Sorry. Kasi minus the non-finger, right? What is the non-finger?
0 and 1.
No, just go one by one. Don't do 2 at a time. 1. Kasi minus 0 divided by what? Just think 2 at a time. 1 and 2. Divided by what? Spit it out.
-1 minus 0.
Correct, exactly. This is the first one. The second one, product, it's a product. It is Kasi minus what? Go to node 3 now. Node 3. You finish this one. Now you go here. Kasi minus?
1.
What did he say?
1.
1 divided by what? Minus 1.
Minus 1 minus 1.
This is N1. This is equal to Kasi minus Kasi times Kasi minus 1 divided by minus 2. This cancels. This is equal to Kasi into Kasi minus 1. How do you know you're right? At Kasi equal to minus 1, what happens? Kasi equal to minus 1, what happens? It's equal to what? Wait a minute. There's something wrong I did. Let me see if I did something right. I might have made a numerical error. I just want to make sure that I didn't.
I think you have to divide the bottom by 2, right?
Yeah, let me do it again, okay? Just to make sure. I just don't want to mislead you. One second, okay? One second. Oh, wait a minute. What the hell am I doing? I'm making stupid mistakes. It's my bad, huh? Yeah. I'm just getting ahead of myself. At cos equal to -1, it is -1 divided by 2, -1, that is equal to 2 over 2 equal to 1. Is that correct, guys? Anyone? You see that? Did you get, do you know how to get N1? Yes or no? See, N1 is 1. At any other cos, at cos equal to 0, at 0, this is at cos equal to -1. N1 is 1. At cos equal to 0 or cos equal to +1, this is 0 all the time. That's a Lagrange polynomial. It's 1 at node 1, 0 everywhere else. Do you know how to get N1? Yes or no? The person who asked me earlier about if you have more than one node, I just trying to answer your question, sir. Yes or no? Do you understand?
Yes, thank you.
Okay, let me ask you one more. Same person, the thank you person. N2. Give me N2, please.
Cos C minus negative
Stop.
1,
second, my screen. Cos C minus
negative 1 over 0 minus 1.
huh? Minus 0 minus 1 minus 1, correct?
Yep.
Times
Uh,
what?
Cos C minus minus 1 over 0 minus 1 minus 1.
Yeah, is this correct? Yes or no?
Yep.
This is equal to 1 plus cos C over -2 times 1 plus cos C over
But
+1.
shouldn't it be cos C minus just 1 for the second term?
0 minus finger, huh? What did you say?
So cos C minus just 1 instead of -1 for the second term. And yeah,
+1 here?
yeah.
Okay, 1 second.
And
Yes or no? Let's do this once more, okay? Because it's too small. for
shouldn't the
me.
bottoms be different too?
Yeah.
Okay, you know what? Let's not forget about all this stuff. Let's come back and do this correctly. 1 second. My pen is acting up a little bit. What happened, right? Let me do the faster way. I go to the longer stroke. Just I will get the whole thing out faster. All right. Let's do N2 carefully once. Here is the picture. This is the picture we're talking about. N2 of Kasi equal. Tell me now. Start. Somebody, whoever started earlier. What is it? Kasi minus? Hello? Anybody?
Kasi
Minus one.
minus one.
No, you're fingering -1. We're going to 1 and 2, and then we're going to 1 and 3. Just focus on 1 and 2 right now. What is it?
Kasi minus -1.
Divided by?
0 minus -1.
What's the next one?
Kasi -1.
Divided by?
0 minus 1.
You are fingering the second node, right?
Yeah.
That's it. You understand? This is equal to 1 plus Kasi over 1 times 1 minus Kasi is equal to 1 plus Kasi times 1 minus Kasi. At 0, Kasi equal to 0, this is equal to 1, correct?
Which node are we fingering?
2, right? The second one, N2.
Isn't it C minus finger for both tops?
The formula says, let me open it up. Finger minus, this is a finger.
Okay, it's minus non-figure. Okay, I had the old one.
Finger minus non-finger divided by,
Yep, that's my bad.
okay. You're okay? It comes out to be 1, must be right. This can also be written as 1 minus Kasi square. At Kasi equal to 0, it's 1, right? Equals to 1 at Kasi equal to 0. That means I know it, I'm right. You understand me?
Yes.
Okay, now same person now. I'm going to hold you. Tell me N3.
So that's going to be C minus -1 over +1.
Minus 1.
Yep, over +1 minus -1. Multiplied by
Yeah,
C minus 0
yeah.
divided by 1 minus 0.
At Kasi equal to +1, what happens here? What is the value? Kasi equal to +1.
Just 1.
Yeah, you're perfect. So you got A plus in the class. Take it to the bank. So you guys know how to generate polynomials now? Yes or no? N1s and N2s and N3s? Guys, are you feeling comfortable? You like the finger method?
Yes.
Isn't it easier than doing the approximation? Yes or no? Approximation, you have to solve A, B, and C simultaneous equations and then figure out all those things. And the more complex the model element is, the more messy it gets. Whereas this one, you simply map and use those in Lagrange polynomials and just say it. Sounds good?
Yeah.
Okay, now, can I move on? Yes or no?
For N2, When you proved that it was correct, what do you get for your final value?
What do you mean? Ah, N2, 1 minus cos square. What the hell is this? Pen suddenly stop writing. 1 second. Why? I need to call my student who got the pen for me. 1 second. Yeah, it's charging. What happened? Did I press something stupid? It's not responding to the pen. Sorry, guys, I didn't. Or either one note is stuck or the pen is not working suddenly. Yeah, it's working now. Can you see the screen, guys?
Yeah.
Yeah.
Huh? What happened? One second, let me make a phone call, if you don't mind. This should not have happened. I got a new one too. I'll put him on speaker. David, Dr. Tama, the pen doesn't respond at all. Why? It just doesn't do nothing. And I put it on the charger and the light comes on, the white light you and I talk about. But otherwise, the thing is not responding. Is it OneNote bad or the pen bad? How could the pen be bad? It's a brand new one. It's not responding at all. Guys, can you hear me?
Yes, we can hear
Folks,
you.
can you hear me?
Yes.
I'll mute you guys just a second till I talk to him 1 second. I can't even mute you. I'm not even able to mute David. I'm not even able to mute them. I try to touch it with my finger, nothing happens. You think OneNote got hung up?
Sorry, the professor is restarting the computer. Let's just wait for like a few minutes.
What do you think? Guys, can you hear me?
Yes, Professor.
Can you hear me? Folks, can you hear me?
Yes.
Yes, we can.
Oh, thank you so much. There was a glitch in the computer. It's a brand new one, that too. That's why I got very concerned. What happened? David, do you know why it happened or just a glitch? Okay. All right. Thank you. I'll catch you later, guys. Take care. Be safe now. Bye. Guys, can you hear me?
Yes.
Yes.
Thank you very much. Sorry, it wouldn't even let me touch it. It doesn't happen. So what I did was just restarted the computer, and then the touch screen and everything worked to the touch and everything. I got out. Sorry for the headache. Where were we? Oh, I know. Do you know how to get N1, N2, N3, guys? Do you know how to use the finger method? Not the long way. The long way is this. This is the long way. Right here. This is the short way. The short way uses the finger method. Do you know how to use the finger method to get N1, N2, N3 in the Casi system?
Can
Yes,
you
please.
walk through again how to prove what you got was correct with N2?
At N2, okay? I'm going to answer your question here. Let me redo N2, okay? You stand by. Hear me out now. I'm going to redo N2 again. Tell me the finger method, how you do, what do you do? N2, finger N2, and tell me what happens. Finger it. Go ahead, sir.
You've got Casi -(-1) over 0 minus -(-1).
Okay, times
Casi -(-1)
over.
0 -(-1).
You agree? You testify this is correct? According to the finger
Yep.
method? If you testify that one, watch this. This is same as 1 plus Casi divided by 1 times 1 minus Casi. Do you agree? Yes or no?
Yep.
This is equal to, if you multiply 1 minus Casi square. Do you agree or yes or no? You don't have to multiply. Otherwise, you agree? No? If you don't understand, at least this is correct. How do you write? What happens at casi equal to 0? What happens to n1, n2? Please answer.
It's equal to 1.
N2 must be 1 at node 2 and 0 everywhere else. That's what. So you know you're right. It should be 1.
Okay, so you're looking for it to be equal to 1 at the end,
Correct.
no
That's
matter
what I told you.
which n
Lagrange
you're looking at.
polynomials. I told you this very clearly here. Lagrange polynomials have an interesting behavior. They either 1 or 0. They're 1 at the place whether you are of interest, they're 0 everywhere else. Therefore, if you have several points like this, at this point, they're 0, 1, 0, 0. They go through zeros. Only one point is 1. This is called a Lagrange polynomial. You understand what I'm saying? At the next point, if I want to here, or here, suppose, here I want Lagrange polynomial. It is 0, 1, 0, 0. It is 1 there. And 0 here, 0 here, 0 here, 0 here. There's zeros everywhere else. Understood?
Yeah, that makes sense now. Thank you.
Yeah, thank you. The Lagrange polynomials have a behavior. They're 1 at the node at which of interest, the 0 everywhere else. I capitalized on that and then did the finger method, saying, finger this one. This is easy to explain this way. If I was live in a class, it would have been much more easier. You know, we're doing on a long time distance computer, and the first time you're going through, I can't expect you to be perfect. I'm not perfect. Therefore, I'm trying to do my best to communicate long distance. Is it okay? Do you know how to apply the Lagrange polynomial method? Yes or no? Yes or no? Hello? Okay, now watch. We'll go back to the clean part of the lecture. Let's summarize what we did just now, and now you can follow the clean part of the lecture. For this two-noded element, mapping to here, do you know how to get n1 and n2 here? Yes or no? Here. Yes or no?
Yeah.
Yes. Now, you use the same what you use for u, you use for x also. This will map it to -1 to 1. Exactly. This is a map. I used n1 and n2 from here. So u of casi is this. X of casi is this. Both are same way. X1 and x2 are coordinates. u1 and u2 are displacements. Do you understand the difference between x and u? Yes or no? X1 and x2 are coordinates. u1 and u2 are nodal values of displacement. Understood? Now I have to evaluate k. This is what I have to evaluate using numerical integration. B transpose of x. B is a function of x. B is a function of casi. Therefore, del B transpose of x is this. You understand this one, right, from your first lecture. But in the casi system, it is d by d casi of n1 of casi, n2 of casi, d casi by dx. This is called the Jacobian. Do you understand this one? Yes or no? Do you understand from here to here? This is the most important part. If you don't know the chain rule. I use the chain rule. U is a function of x. U is a function of casi also. Therefore, du by dx is dn1 by dx, dn2 by dx. But in the casi system, it's d by d casi of dn1 by d casi and dn2 by d casi and d casi by dx. That's what I did. Is this clear? This is a matter of algebra for you. This, forget about these two, forget about these two, forget about these two, forget about these two. I'm trying to evaluate K. This is like f of x dx. Integral 0 to L f of x dx. Do you agree? All of you? It's like f of x dx? Yes or no?
Yes.
Some function of x. Therefore, but b is du by dx. B of x by definition is du by dx. But u is n1, n2, and u is equal to this one, right? In the x system, it's dn1 by dx, dn2 by dx, b. But now I'm changing it to Kasi system. It's d by da Kasi of dn1 by d Kasi and d by dx Kasi of dn2 by d Kasi times d Kasi by this. This is u part in Kasi system, u part. So if I take the mess out so that you'll see it clearly. Do you understand this step? Here, B, sorry, I'll do a better job than that. U of x equal to n1 of x, n2 of x times u1, u2. B of x is du by dx. That's equal to dn1 by dx and dn2 by dx. Is this clear? That's what this was. But I don't want it in the Kasi x system. I need it in the Kasi system. Therefore, I use chain rule. One second. Again, it froze. 1 second. Oh God, what is it? Something wrong with OneNote or what? Something stuck. What happened? Can you see the screen, guys?
Blank.
White.
What happened? I lost everything? Oh God.
I
No.
think he selected everything and then deleted it somehow.
I deleted? What happened? What is this?
No, I think you're just in another page.
Yeah, you just said I deleted everything. I scared the hell out of me. 1 second. You think what I probably deleted was? Let me do one thing, if you don't mind. I see. I think I deleted everything I wrote. Is that right? No? Doesn't matter what it is. Let's go back over here. Can you see this page at least? Can you see this page? Yes or no?
Yes.
Okay. Maybe I deleted by mistake, like you just said, all the thing I wrote. Not the page. This is in your notes. This is the objective, right? This is, you want to evaluate this one. B of x is du by dx, correct? B of x, you get from du by dx. That is dn1 by dx, dn2 by dx times u1 and u2. This is b1 and b2, right? That's what this is. Do you agree for this one? Do you understand that? Now from here to here, do you understand how to get this one? U is a function of x. U is also a function of Kasi. Therefore, du by dx is equal to du by d Kasi times d Kasi by dx. This is chain rule. You agree? Hello? Again, once more, let me repeat.
Yeah.
Let me repeat. U is a function of x. U is also a function of C. Therefore, du by dx equal to du by d C times d C by dx. Do you agree to this? Yes or no? Chain rule, CR. Yes? Unless you say yes, I cannot move. If you don't know the chain rule, I cannot help you.
Yes.
That makes sense.
Now, du d C by dx is this one, and du by d C is this one. Do you agree? Right? U of C is equal to N1 of C, N2 of C, U1, U2, right? Therefore, du by d C is equal to dN1 by d C, dN2 by d C, right? That's what I did here. Can you see that? And dx by d C, x equal to N1, N2, we mapped it, right? X1 and X2, correct? Therefore, dx by d C equal to dN1 by d C, dN2 by d C times x1 and x2. If you do the algebra, you get b equal to this. Do you see this? Look at it carefully and see if you understand it. If not, I'll explain. Slow. Do you understand how to get b in the Cauchy system? This is b in the Cauchy system as well. Now, k equal to, watch k, 0 to L b transpose dx. I don't want to do this. I want to do it in the mapped system now. So minus 1 to 1 b transpose b, and dx by d C right here is L over 2. And this is equal to EA over minus 1 to 1 d C. But Gauss said minus 1 to 1 d C equal to WIFI. Therefore, if you open this up and do the algebra, you get EA over L into 1 minus 1 minus 1. Do you understand what happened? How to use Gauss integration to get stiffness matrix? Yes or no? If something is bothering you, tell me where and I'll stop to hear from you. Let me teach you another way, if you are not comfortable. I'll take an alternate route on explaining to you. The notes are the same, but the style of teaching is probably different. So maybe if you didn't understand the first time, you understand the second time is what I'm hoping for. And let's see what happens. All right. Let me see if I can get my act together in a different way. I want to evaluate K using, I want to evaluate K using numerical integration. I don't want this one. I need to evaluate K equal to integral minus 1 to 1 B transpose of C B, sorry, my bad, crap. E B of C D C, and the answer to this is some WI FI. Do you understand my motivation? Suppose I cannot do this integral here. I want to do this one instead using Gauss integration. Is my motivation clear? Yes or no? Unless you
Yes.
give me feedback, I won't know what's going on.
Yes.
That makes
Okay,
sense.
now, so my question is, I know B of x is du by dx. What is B of Cauchy? I don't know. Do you understand? You understand? So what is B of Cauchy is what I'm asking right now. Do you understand my motivation?
Yeah.
B of x is du by dx. Your high school English teacher taught you that. When you were young and going through high school, she told you du by dx is strain. But du by d Cauchy is not strain in Cauchy system. It is something else. Let me repeat myself. The original length in a XY system, X system, is not the same length in the Cauchy system. It is Jacobian times the new length. Do you understand that? It's a Jacobian of the transformation. An area in the X system is not the area in the Cauchy, same as the area in the Cauchy system. It is the new area times the Jacobian. A volume in the potato in the X system is not the same volume in the Cauchy system. It is the volume in the new Cauchy system times the new volume times the transformation mapping, Jacobian. Do you understand that? In other words, what happened here, man? This length L is equal to L nu times the Jacobian. This area A is equal to A nu times the Jacobian. This volume is equal to nu volume times the Jacobian. Jacobian is dx by dx in the 1D system. Let me show you why. Now, having said that, I'm just trying to come up from a different point of view, so hopefully you won't miss it. So what is B of Cauchy and eta? Oh, what is B of Cauchy and eta? It's as follows. All right. B is dux by dx. That is dn1 of x dx, dn2 by dx of x, u1, u2. We know this from a high school. Du by dx is strain. Now, but u is a function of x. Since I'm mapping, u is also a function of Cauchy. Therefore, by chain rule, du by dx equal to du by d Cauchy by dx. Do you agree? Do you understand this step? Yes or no? Therefore, if you take this one, this same as saying dn1 by dx, sorry, Cauchy, dn2 by d Cauchy times d Cauchy by dx, d Cauchy by dx. That's what this is about, this step. Same as this one. Can you see that? Yes or no? See that? Compare this one and compare this one. Are they the same? Yes or no? That's how that was done. Yes or no?
Yes.
Chain rule. I just apply, instead of this, I applied the chain rule and took this. That's what I did. Okay? Is this okay? What's so troubling, if I may ask you, that you're not responding? I just want to know. Otherwise, I'll never know. I want to know what bothers you. Because if it's painful to me too. Because You have to know the chain rule. And I'm just simply executing the chain rule, that's all. This is okay.
Yes.
Okay, now, if you said that, now watch. I'm going to do something clearly. I'm going to evaluate this term. X is equal to N1 of Kasi, N2 of Kasi times X1 and X2. Are you interpolating X? Here, this one. You agree? These two are equal? This one? Yes or no?
Yes.
This is 1 minus Kasi over 2. This is N1 plus Kasi over 2. So what is dx by d Kasi? Equal to dx by d Kasi equal to this. Do you agree? Keep in mind. So if you take the derivative with respect to x, x1 and x2, right? This is same as saying 1 minus Kasi over 2 x1 plus 1 plus Kasi over 2 x2. When you take the derivative with respect to Kasi, you get this. But x2 minus x1 is there. The nodal coordinates is this, x1 and this is x2. x2 minus x1 give me the length L. Therefore, L over 2 dx by d Kasi is equal to L over 2. This is Jacobian. Do you understand what I'm trying to say? Yes or no?
Yes.
If you understood that, therefore B of x is equal to B transpose, B of x is equal to minus 1 over L, and this one is d Kasi by dx. This is B transpose, E, B, dx Kasi. This is what I have to do now, because I'm in the Gauss domain. But the answer to this is equal to this. If I do the algebra, actually, I think I can see a problem here. Why you may not understand it. It's my bad. It's a typo on my part. I can see this. This is not here. Put wrong. This is wrong. Because if you multiply this out, you don't get this. You get this outside and this left behind. So you get, if you multiply that out, you get this times this part is this. Can you see that what I just said? I made a statement. I want to make sure you understood where I made an error. I made an error. If you multiply this one, you will get E A L over L square times 2 times minus, 1 minus 1 minus 1 1 times integral minus 1 to 1 d Kasi. This is what should have been here. I made an error in this step. Is this clear? Yes or no?
I believe there's an error a couple lines up as well.
Where, please?
In the
You
X.
see, these typo errors sometimes happen. You see, I'm trying to write my lecture notes in. Go ahead, please. Go ahead before.
It's right under therefore. So
Therefore,
scroll up a little bit further.
Yeah.
that blue circled equation just off the screen, I think there should be a plus in that second rather than
Blue
a
circle
minus.
equation, which one? Which one?
You have a
Yes, you're right. You're absolutely right. You're right. This is wrong. You're right. Thank you so much. I noticed it earlier, thought I'll tell you, but I forgot. Yeah. There's some typos here and there. Thank you very much. You got 5 points for pointing that out to me. I noticed it earlier in the afternoon when I was looking through the notes, but then I forgot about it. You understand? But anyway, do you understand how to come from here to here? Now, what is integral minus 1 to 1? This is Gauss theorem. The answer is WI/FI. And if I do WI is 2, because it's a linear line, WI is 2, the function of cos is 1. Therefore, if you take a look at it, 2 cancels with 2, and you get EA over L times this one and this one. So you got back this. So do you understand how to get K using numerical integration? All you have to do is to program this one. Code this one. If you have to write a computer code. Let me show you the 3-noded one so you can understand better. All right. Let's do this. Here is a 3-noded one. You can do the long way or the short way to get the end. This is the long way. At x equal to x1, cos is 1 is 1, x equal to x2, cos is plus 1, and x equal to x3, cos equal to 0. This is 1, this is 2, this is 3. Alternate. It's, I don't know why Pranav did it this way, but it's not done this way. But anyway, when you apply to these ones, you get, you solve for A1, A2, A3, you get these. You saw these before. Do you know how to get the ends? Yes or no? Yes or no? I thought we went through this rigor earlier. Earlier we did the short way. This is the long way. Do you understand? Here. You assume a quadratic. You apply the conditions and get the ends. That's all. Now, x is equal to this one. And then you get n1, n2, n3 the long way. So do you know how to get n1's, n2, n3 the long way and the short way? Yes or no?
Yeah.
yes.
Okay, now I just want to show you with 3-noded element how you get the ends. Let me now go to quadrilateral. Do you know how to get K for a 2-noded element? Yes or no? K, the one we went through a little while ago, this one. Do you know how to get this one? From here, this step to this step, yes or no? In principle, you can see this, right? B, chain rule, get the thing, put it here, use instead of integral 0 to L, do minus 1 to 1, apply Gauss theorem and get this. Clear?
Yeah.
Now let me do 2D before you go home. You'll really find it exciting. Really exciting. You're gonna get a kick out of it. We will call this one 1, 2, 3, 4. Let me do some color coding. If you give me a quick minute, I'll be able to help you out. Sorry, I didn't mean to do that. The blues are the Cauchy. Stop. The blues are the Cauchys and the reds are the etas in the 2D system. I'm mapping from here to here. I'm trying to get x is equal to n1, n2, n3, n4 times x1, x2, x3, x4, and y equal to same thing times y1, y2, y3, y4. That's what I'm trying to get. What are the ends I'm trying to ask? Now watch. N1 of Cauchy and data equal to what? Use the finger method and finger Cauchy first. Go here and finger Cauchy first. What happens? Tell me, read it to me. Read to me what happens. Go in the Cauchy direction. This is node 1, 2, 3, 4. Read me N1. N1 is what? Finger Cauchy. Finger Cauchy here. So it's Cauchy minus what? Cauchy minus 1 divided by minus 1 minus 1. Do you agree? Yes or no? In the Cauchy direction, in the x direction. This is what I did first. This one. Did you get it? I'm trying to find N1 of Cauchy and data in 2D.
Yep, got it.
Times. Now go to eta direction. Stay on 1. Eta direction. I'll do blue. Do you get it? Yes or no? This is N1 of Cauchy and data. This is equal to 1/4 of 1 minus Cauchy times 1 minus eta. Eta equal to minus 1 and Cauchy equal to minus 1. N1 is equal to 1. Do you see how to get in 2D for Cauchy and data? Do you know why this is so difficult? If you know what is a Pascal triangle, this is constant linear for triangle. For quadratic, you need to take these. So you have to take u is equal to a plus bx plus cy plus dxy and v equal to similar and solve for a and b and a, b, c, d. You get u and v equal to n1 0, n2 0, n3 0, n4 0, 0 n1, 0 n2, 0 n3, 0 n4 times u1 v1, u2 v2, u3 v3, u4 v4. You get this is how the construction looks like. This is a long and tedious way of getting ends. Impossible by time you figure out. But I can finger this and get the ends in the Cauchy system. Do you know how to finger it and get it in the Cauchy N1? Do you understand that? Let me try N2. Somebody, I'll give you 5 points if you tell me N2 exactly. N2 of Cauchy and data. Finger N2. Go first in the Kasi direction, then go in the eta direction. That's it. Try, please. Try this. Somebody try it, please. You got 10 minutes. Finger Kasi. Finger Kasi. This one.
So that
Finger
would
it.
be C minus -1 divided by 1 minus -1.
You get 5
times-
points, guy. You got 5 points for that. Next one. Do the eta one now.
You're going to multiply eta minus 1 divided by
Eta what? Fingering 2, no 2. Eta minus what?
1.
What?
Is it not minus +1? You go to the closest eta?
Damn, eta is, you're fingering this, right?
Yep.
Eta minus what? You're fingering this one. Therefore, eta, what is eta here?
It should be 1.
Oh, God. Come on. Either you're sleeping or I'm sleeping.
Aren't you going in the, you go in the eta direction,
Oh,
which is
shoot.
up.
I'm feeling sleepy, guy. I'm my bad. Eta minus
1,
1 divided by
-1,
minus 1, correct?
-1.
Yeah. Sorry, I'll give you 10 points. I made a mistake. Sorry. Okay? So this is equal to 1/4 of 1 plus Kasi into 1 minus Kasi. You agree? Oh, sorry. One minus eta. You agree? At Kasi equal to +1, it should be 1. It should be, no.
No, I think what you had was correct.
Yeah. Yeah. Correct. Is it okay? Now read me N3 without doing anything. Just read me N3. You know the answer, it should be 1. There were 1 plus Kasi into 1 plus eta. That's it. At Kasi equal to +1, eta equal to, is easy. You can generate this in a hurry. What is N4? You can mentally, you'll be so sharp now. What is N4? How do you get N4? It is 1/4 of 1 plus eta into 1 minus Kasi. Right? At eta equal to +1 and Kasi equal to -1, it is equal to 1, right?
Yes.
See how you generate it fast using Lagrange polynomials? This is a crap, this stuff, this way, the long way, which they do is crappy. Therefore, we do this. Do you read me?
Yeah.
Do you know how to get n's in the 1D and 2D? Yes or no?
Yes.
Okay, one more. I got still 6 minutes. This is called an 8-noded brick element. You map this into -1, 1, 1, -1, -1, 1 in a cube. And then you can generate likewise. This is Kasi, eta, and zeta. You do the same. Kasi direction is this way, eta direction is this way, zeta direction is this way. and the same thing, and you get for 8 noded also in the same way. Do you get the idea, basic idea behind the whole thing? I will have the TA go through this with you, but do you understand this one, yes or no?
In principle, yeah.
In principle, listen, this is the X direction. Sorry, let me change the color. This is the X direction. This is the Y direction, and this is the Z direction. Therefore, it's Kasi, eta, and zeta. Kasi, eta, and zeta. So you finger this one, go with the Kasi direction first and get it. Then finger this one, go in the eta direction and get it, and finger this one again, and go in then move to the next node. You keep on going and generate it. Otherwise, it's very crappy. You know what you have to take? You go the long way. You go to the Pascal, this thing. It is like this, the Pascal triangle is like this. 1 constant, x, y, z, x square, xy, y square, yz, that. You have to take all these terms and all, and assume u of x is equal to a plus bx plus cy plus dz plus some term. It's a mess solving these equations to derive the n's. I need the n's and the b's to construct my k and f. But this is a short, faster way using finger method. That's all I'm trying to get at. Sounds good, guys? Do you, at least in principle, I'm not telling you to be an expert. In principle, do you understand the concept of generating interpolation functions for isoparametric formulation? That's all I care.
Yeah, sounds good. That's
Okay. You earned it. I'm going to let you go. Thank you very much. And be safe as always. And thanks for participating.
Yeah. Thank you, Professor.